Here we go. So today we're going to learn 1-4, measuring segments. Your very first postulate, so your very first flashcard, if you happen to have looked at them, is called the Ruler Postulate. You need to learn it. If I ever give you any homework assignments, because sometimes I oops and I inadvertently give you one, where you have to construct something, like draw something with a compass, skip it, don't do it, because we don't do constructions since we do the whole curriculum in 3 quarters. We'll do constructions 4th quarter. All right, so here's what the Ruler Postulate says. You're going to write down all these words, and we're going to have a picture. So the words are going to be gobbledygook to you until I explain them to you. Okay, so don't panic about the words until I explain. So the Ruler Postulate says the points, yep, write this down, on any line can be paired with real numbers. Real numbers are any number you could possibly think of. Question? I don't give out pencils. You can borrow from a friend or take notes in pen right now. So that, given any 2 points, we are going to call them P and Q, but it could be -5 and 10, or it could be a decimal or a fraction. So 2 points, P and Q on the line. P corresponds to 0, and Q corresponds, I told you not to panic at all the words, to a positive number. The point of this is just that no matter what the numbers are, maybe P is -5 and maybe Q is +10. And we're finding the distance between the numbers. Technically, they're going to say, what they're saying is that that P, which is -5, we're going to relate it as if it were 0. As if we're taking a ruler that has 0 on it. Now this ruler is hard to see, it's very old, but it starts from 0 and goes all the way up to 6. So if I were to measure anything with a ruler, don't I start with the number on the left and I start it at 0 and I measure how far that is and take a measurement, right? That's all they're saying. You always start at 0. So if I'm going to measure something, if I'm measuring a point that's from here to here, let's say, I don't start it right here and measure it. Does that make sense? Yeah. I'm going to start it right here at 0 and measure how far it is. That's all they're saying. That's why it's called the Ruler Postulate, because if you were taking a ruler, you would set the ruler at 0 and measure how far it is, no matter what the numbers were. And so here's a picture. Draw yourself a line. This is P and this is Q. So there are 2 points, P and Q, on that line. And all this says is that no matter what the number P it represents, no matter whether it's a positive number or a negative number, we're going to say that that P, we're going to change its value to 0. And I'm going to measure how far apart they are, and this should be some positive number. Do we ever measure distance negatively? No. So if you're measuring the distance between 2 numbers, it will always, always be a positive number. Phil, you okay? Do you need to go, nurse? Okay. All right, so for instance, what if we had this? Yep, we're going to draw another one. We're going to put real numbers to this one. So let's say that we have x here, And you'll see in just a minute. We're going to do a real example. I'm going to put a real number to x. I'm going to put y there. Count the same distance away as I did. I'm going to give x a value of 2 and y a value of 14. How would we normally find the distance between 2 and 14? We obviously are not going to take a ruler and go and measure. There's two different ways that we could measure the distance between those two numbers. Actually, 3 different ways. Yes? Subtract, right? Does it matter which one is subtracted from which one? No, we're going to subtract these two numbers, right? You could either do that, or couldn't you count the units in between if it's to scale? So how many jumps do I have to make from 2 to 14? If you counted on here, would you have 12? So the distance between 2 and 14 is 12. So if I actually, and here's where the ruler postulate comes into play, if I made this 0, and this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, wouldn't this be 12? That's all that ruler postulate says. It doesn't matter what these numbers are. We're going to take one of the numbers, make it equal to 0, and then count how far it is from the other number, and it should be a positive number, positive distance. Well, we don't want to have to do that every time, do we? So hopefully you realize that we're going to take either 2 minus 14. Why did I use absolute value signs? What does the absolute value signs give me? Esteban? A positive answer, right? In geometry, if I wrote xy like this equals nothing above it, nothing in front of it, it's understood that I'm asking for the distance of measurement xy. I didn't put a line segment up there because that would imply line segment xy. But if I give you 2 points with nothing above or in front of it, it's implied the distance of xy. And so doesn't that equal 12? Or the distance of xy, you should get exactly the same answer if you did 14 minus 2, don't you? Either way, you'll get the same result. And so that's all you're doing. And we're going to put units here because we don't know what they were. So super simple. Second postulate, you ready for that? Pretty basic stuff. 1-2, this was actually 1-1, but you don't ever have to memorize the postulate number. 1-2 means that it came from chapter 1 and it's the second postulate in the chapter. Do not tell me if I asked you to describe the postulate associated with a particular example, do not call it postulate 1-2 because I'll mark you wrong. I don't know what postulate 1-2 means because I don't memorize them by postulates. What if you go to another school that has a different textbook? Are they going to call it postulate 1-2? Nope. They'll call it something else. So don't memorize numbers. What I do want you, if it has a name, you can memorize the name. This one actually has a name. It's called the segment addition postulate. And it's used often. We will use this all the time. It says if Q is between P and R, then PQ plus QR. Do you notice the notation? I just had PQ. What does that mean? The distance from P to Q plus the distance from Q to R. Remember, I just told you that was new notation. If there's nothing above or in front of, it's relating to the distance between those 2 points. Should equal the distance from P to R. And then oftentimes you're going to have the reverse. And we're going to talk about reversing and what they're called. But we're going to reverse this. They're going to say it exactly the same, but they're going to say it backwards. If PQ plus QR is equal to PR, then we can conclude that Q is between P and R. So if you're told that Q is between two letters, then you can conclude that the sum of those two segments is equal to the bigger segment. Or if you're told that the two smaller segments equal the bigger segment, then you can conclude that this Q that's doubled here must be in between those two. A picture is worth 1,000 words, right? Wouldn't it be nice to look at a picture of this? On your flashcards, there are no pictures. So you need to add these pictures to your flashcards. Your flashcards are not completely done. You need to finish them off. So we're going to add a picture to show what this means. So draw a number line. If I asked you to draw what this is saying, this is what I would expect you to draw. It says if Q is in between P and R. Does it say it's directly in the very center between P and R? There's nothing that implies that, just that it's somewhere in between. So if I put P here and R here, Q can be anywhere in between here. It could be right here, 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 anywhere, right? I'm going to, for chuckle's sake, put Q there. Why? Because I feel like it. You could have put it anywhere else. So let's put some numbers to this number line. So let's say that this is 2. That means this would be 5. And that would be 11, right? And all this says is that, what's the distance from P to Q? How far is it from P to Q? 3. How far is it from Q to R? 6, right? So what's 3 plus 6? 9. What's the distance between 2 and 11? 9. So all this says is that the distance from P to Q, 3, plus the distance from Q to R, 6, is equal to the whole distance, which is 9. And if I had told you all of this, that this plus this equals the whole distance, all they're saying in this one, Q must be in between them. All right. Let's look at an example. Question? Yes. Will you pass this back, please, to Esteban? All right, so let's look at an example. Example 1. Here's what the types of questions you're going to have in your book. It says, find the measure of, what does this notation mean? Line segment MN, right? So find the measure of line segment MN. I could have written it just find just MN with nothing above it, and it would have said the same thing. If I had just put MN with none of this measure of here, and no segment above it, it would mean the same thing. If N is between M and P, and then they're also going to be told that MN, what does that mean? The distance between M and N is equal to 3x plus 2. NP is equal to 18. And MP is equal to 5x. They're not going to give you a picture. What do you think you should do? Again, a picture is worth 1,000 words in geometry. If you're trying to do this in your head without a picture, you're doing the wrong thing. So you have got to draw a picture. So the very first thing that I would do is draw a picture of what they're describing. Find the measure of line segment MN. And they're telling you N is in between M and P. They don't tell you how far it is, so don't stress about, do I make it directly in the middle or which is bigger? Don't worry about that. If you draw your picture wrong and you put the smaller segment as the bigger segment, it won't matter, really. So don't stress about that. So we're going to draw a line segment. We really don't know how long to draw it, and that's okay. And I'm going to put m on the left, and we could be wrong. M could be on the right, who knows? And I'm going to put, oh, I'm sorry, oh, m is between. So I'm going to put p on the right. And n is somewhere in between, right? Does it matter where? No. That's an M. Shocking but true. See why my mom wouldn't let me fill out my wedding invitations? There's your M. All right, so let's fill in what they told us. We know that the distance from M to N is 3x plus 2. So I'm going to put a 3x plus 2 here. And then they told us the distance from N to P is 18. So the distance from here to here is 18. And the whole distance from M to P is 5x. So I'm going to put down below 5x here, and it represents the distance from here to here. What postulate are you going to use to set up your equation to solve? This would be typical to our let statement. Now you have to write the equation to solve. I don't want to see scratch work. I want to see algebra. What postulate tells us how to solve this? The segment addition postulate. The two smaller segments add up to equal the whole bigger segment, right? So that's how you're going to set up your equation. We're going to take the smaller segment, so we're going to take 3x plus 2. We're going to add to that the other segment, 18, and shouldn't it equal the entire big segment? What's the length of that big segment? 5x. Does everybody understand how I set that up? No. Wouldn't you agree, ignore the numbers, that this piece plus that piece should equal the entire whole piece? This little piece from here to here, if I took that value and added it to that value, wouldn't it equal the whole big piece? Yeah. That's what we're doing. So we took this little piece here, 3x plus 2. We added 18, the second piece, to it, and it should equal the entire big piece. They told us that from M to P was 5x. Are we all okay? Now we use our algebra. The rest is a piece of cake. This was the hard part, setting up that equation. So identify your like terms. What's a like term on the left? The 2 and the 18. So I want to see that work. 3x plus 20 equals 5x. You have a variable on both sides of the equal sign. Which one should you move? Right, we want to move the 3x that's smaller. So I'm going to subtract 3x from both sides, and I get 20 equals 2x. Now what do I do? Divide both sides by 2. Your algebra should look exactly like my algebra. And so x is equal to 10. Was that the question? Does this answer the question? No, it does not. This is just the value of x. They want to know, find the measure of segment MN. What's the value of segment MN? 3x plus 2. So don't we plug in to find that? So MN is equal to 3x plus 2. We're going to plug and chug. We know that x is 10. 3 times 10 plus 2. I don't want you doing it in your head. Because if you make a mistake, I'll mark it completely wrong instead of giving you partial credit. And that's why it's to your advantage to show your work. So we get 30 plus 2, which is what? 32. So MN is equal to 32. That's the answer that we were looking for. Not all of them are like that, but many of them are. So your whole goal is to find what are each of the smaller segments equal to, what's the whole big segment equal to, and the ruler postulate says add those two smaller segments and set it equal to the bigger. So we're using that postulate to set up our equation to solve. Okay? All right. Then we can also use Pythagoras Theorem. So that's the other one that we're going to look at. We can use Pythagoras Theorem to find the length of segments. All right, Pythagorean, surely we know Pythagoras Theorem. Yes. Thank you. Esteban, you need, oh, I still have it up there, never mind. Pardon? I'll send it back to you. All right, so Pythagoras Theorem says, and by the way, it only works with what?
Right.
Yes, with right triangles. So it only works with right triangles. And it is a squared plus b squared equals c squared. Well, what does that mean? So we're going to draw a little right triangle, and we're going to label it. Okay. What does C represent on Pythagoras triangle? Ricky? The hypotenuse. And which side is the hypotenuse? It is the longest side. Which is the longest side? It's always across from where? There you go. The longest side of a right triangle is always directly across from the right angle. It is called the hypotenuse. We label it C. So this is your hypotenuse, one of my favorite words. And then A and B represent what we call the legs of the right triangle. And it doesn't matter which is A and which is B. And so this represents a leg and a leg. So Pythagoras Theorem says if you take the sum of the square of the legs, it will always equal the square of that hypotenuse. Surely you've seen this since 8th grade, I would hope. All right, so we're going to use it to help us out. So here's your problem. Example 2. Example 2. You are going to find the distance between points H, which is 2, 3, and K, which is -3, -1, by using the Pythagoras Theorem. So what should we do first? What would be the very first thing you should do? Ricky, what do you think?
Find the length of the legs.
How are we going to do that?
Usually we can
Shouldn't we plot these points first?
plot. Oh wait, right.
Yeah. We could use the distance formula, but technically we haven't learned that yet. So we're going to plot these points first. So make yourself an XY axis. Okay, so we're going to plot the points, which is why we went over plotting. So H is 2, 3. So to the right 2 and up 3. Here's H. And K is -3, -1. So that's to the left 3, 1, 2, 3, and down 1. This is K. We want to find the distance from here to here. Can we count that distance like we would on a number line? Can you count that?
Yeah.
It's diagonal. I can't count that. The diagonal of a square is not the same as the side of the square, so you cannot count from here to here. But couldn't we create a right triangle? Couldn't I make the legs of a right triangle? If we look at this as being our hypotenuse, so we're going to let this equal C, the hypotenuse. We're going to let that distance that we're looking for be C. And then you're going to create legs. Can't we find the distance of the legs quite easily? There's our right angle right there. Can't we find the distance of those legs? We can count those squares, can't we? How far is it from H down to here? How far? How many units? 4 units, right? If you count, there's 4 squares, 4 units. Then how many down here from here to K? 5 units, right? Can't we use Pythagoras Theorem, throw it into this formula, and find the hypotenuse? That's what we're going to do. So we will start with a squared plus b squared equals c squared. Does it matter which is a and which is b? Makes no difference. So we are going to plug in for a, either 4 or 5. I'm just going to put in 4. Square it. Then we're going to plug in 5, square it, and we should come up with c squared. What's 4 squared? 16. What's 5 squared? And then equals c squared. What's 16 plus 25? 41 is equal to c squared. How do you remember how we solve when we have a squared variable? What do we do to both sides to get rid of that squared c? We take the square root of both sides. So we are going to take the, what if I take the square root of c squared, what do I get? C, yes. And if I take the square root of that, is that a perfect square? No. I want you to leave your answer as a perfect square. Now, if your book says give your answer to the nearest tenth, I want to see this answer first. And then if you want to use a calculator, or you could estimate it, can't we estimate that pretty close to the nearest tenth without a calculator? What perfect square is to the left of 41? 30, not 36. 6 is not a perfect square, but 36 is the perfect square, right? So 36 would be to the left, right? Correct? And what perfect square is to the right of 41? 49. And the reason why we're using 36 and 49 rather than 6 and 7 is because 41 is closer to which one? 36 or 49? How far is it from 36? 5. How far from 49? 8. So which is it closer to? So we know that the square root of 36 is 6, right? And the square root of 49 is 7. Somewhere between 6 and 7. Halfway in between is 6.5. Are you going to go below 6.5 or above 6.5? Below. So what would you estimate it as? 6.4? I would probably say 6.3. And I'll tell you what it is in a minute. So I would say 6.3. And then if I grab my handy dandy calculator, the square root of 41 is, 6.4. Those of you who said 6.4, you were correct. And I will, I will typically give you a tenth of a leeway on either side. So we would have still been correct. All right, but you definitely want to leave your answer in full radical form if it's not a perfect square. Okay? All right, ready for the last examples? We got 2 more. Yep, 2 more. You can do it. Esteban, do you need this? Okay. So if you would pass that back. Guys, pass it, Danny. Pass that back. Okay. Remember I said we could use the distance formula? Well, here we're going to do it. So example 3. You should have been introduced to the distance formula in algebra last year. We are going to use the same points from example 2. But find the distance of HK using the distance formula. The distance formula is on your Ames reference sheet. I don't expect you to memorize it. I will always let you use that sheet on your test, but you do need to know when to use it, what it is, and what situation you use it for. Here's the distance formula. D is equal to the square root of, and you're going to take the difference between your x values and add to that the difference between your y values. The x sub 1 and x sub 2s, those sub 1 and sub 2s just means that you have 2 x values and 2 y values. One belongs to point 1, one belongs to point 2. So if we use our same points from the previous example, what was the ordered pair for H? 2, 3. And what was the order pair for k? -3, -1. So all these mean is that you're going to assign it. It doesn't matter which one is x sub 1 and which one is x sub 2. You assign it and then keep it. It doesn't matter. I'm going to say that one's x sub 1, y sub 1, and this is x sub 2, y sub 2. If you reversed it, it won't matter. You'll still get the same answer. So we're just going to plug in for each of these. We're going to replace those with them and then do the math. So here we go. HK is equal to the square root of, and then we're saying x sub 2 is -3 minus x sub 1 is 2, parentheses squared, plus, and then replace y sub 2, which we said was -1, minus y sub 1 is 3 squared. Everybody okay with that? Anybody not understand where I got those? All I did was take the original formula and replace your 4 values here with what we just termed them to be, and I put them here. Now we're going to do the math. We don't ever subtract in algebra, we add the opposite. So I'm going to change the -2 to plus a -2, and the -3 to plus a -3. So what's a -3 plus a -2? -5. So we're going to take -5 and square it. What's a -1 plus a -3? -4, and we're going to square that. What's -5 times -5? Positive 25. What's -4 times -4? Positive 16. Whenever you square these, both of these had better be positive numbers, because if we square a negative, it always becomes positive. What is 25 plus 16? Isn't that the answer we came up with before? Two different ways, same answer. Some of you will prefer this way. Some of you will prefer example 2. It depends on your brain and which way of thinking your brain is more geared to. If you're given a choice, you can choose whichever way you want. But if you're told which way to use, you better use it that way. So if you're told to use Pythagoras Theorem, you have to use it. If you're told to use the distance formula, you have to use it. But given a choice, you can use either one. And then actually, I don't have one more example because we're not doing construction. So that's it. Any other questions? Good.